Hello, everyone. My name is Marta Franca. I work in CYPE, and today we are going to introduce you to CYPE Connect. And in particular, we are going to introduce you to the new features for design to steel to timber structures with CYPE Connect. My colleague Afonso Lac is the Digital Marketing Director and is there with me. Hi,
Afonso. Hello, Marta.
Hello. I wanted to show you this slide because this is my email address, just in case you need to send me any requirements or any questions. So marta.franca@cype.com. And I also wanted to show you where you can download the software. So I'm going to share this link, so don't worry, you don't have to write it down. So in here you can see our website, and here you see the button where it will take you to our platform called BIMserver.center, where you can download the application. But also you have here some information that is interesting as well. Here in this button you can press it and you'll have the resources to learn how to use the software. But if you press here, I'm going to show you, it will take you to our BIMserver.center application, and here you can just click on here and download it. You also have the available resources here for any information extra you want to have about this application. So for me, I think this is all I wanted to say for the beginning. I will pass the controls to Afonso now, so he can show you the new feature, as I said. And after, sorry, Afonso, when you finish, I will come back again and show my email address again and how to download it, just so it gets clear.
All right. So thank you very much, Marta. During this section, if you have any doubt, any question, you just have to open the chat option that you have on your right side. So you can send a message, ask something. During the presentation, we will be here. Marta will be typing and I will be talking. So if you have any question, you can write it. And you can also send a message directly to Marta by mail if you don't have the opportunity or the time to make it during the presentation. Okay, so please contact us if you have any doubt. You have this option too. Okay, Marta, I think before we share my screen, we'll be working with some softwares here. I think it's going to be better if we turn off our cameras. Just because it will save some resources. So I will turn off mine.
Me too.
And I think it's ready. So let me show my screen. Just a second here. Just a second here. All right. So from this moment, I think you can see my screen. If you please could confirm, Marta.
Yeah.
All right. Okay. First things first. After downloading the software, as Marta was saying, we must know the workflow that can be adopted when we are using the application CYPE Connect. Design the connections, it's at least a second step in our workflow, okay? Before we design the connections, first we must design the structure, define the size of the sections, the loads, the combinations, the codes that are used to check this structure. And to do that, we must use other applications. For example, we could use CypeCAD or Strubing Cype 3D, okay? In this workflow, in this presentation, we'll do this workflow here. We will start from an architectural model that was developed using the application CYPE Architecture. This architectural model will be used to design the structure, the wooden structure in this case. The application that will be used is Strubing Cype 3D, and then exporting the IFC file from this structural model, we'll calculate for each node of this structure one connection, okay? One specific connection for each node considering the loads that were applied on this structure. In some cases, even adopting the information that can come from the architectural model. Okay, so this is our workflow during this section. So the three programs that I have been talking before, you will find them on the BIMserver.center store, just searching for the names on the search bar. And I have the same programs here, okay? So I have the architectural model here with CYPE architecture, then the structural model, and then we will start a new connection with CYPE Connect in a few moments, okay? Starting from the architectural model, this is the little house that I've prepared to this presentation. It's very, very simple. It's a wooden cottage or a wooden house with wooden walls. Okay, very, very simple. If we deactivate here the layers that were created here on CYPE architecture, you can see that the wooden structure is behind the architectural model because the structure is already developed, and using the buttons that we have here, you can see that I'm connected at the BIMserver with my account of the BIMserver.center platform. There is a project that was created with this name here. You can see that is in the green state, we are connected. And we can send the different files, the different IFC files of the different programs that CYPE have using these two buttons here. We can send information from one software to another, sharing information, for example, from CYPE architecture to Strubing CYPE 3D and then CYPE Connect, for example, okay? And update information, we can receive information, we can get information from other softwares to the and download this information, these IFC files, to the software that we are using at that moment, okay? So here you can see that we have now, two layers, two different different IFCs, one to the architectural model, another one to the structural model, and we are creating this project with at least two layers, and now we add a third one that would be the connections, okay? So the second layer here at Strubing CYPE 3D, this is the analytical model that was developed considering the geometry that we developed before at CYPE architecture. Here in the tools tab at Strubing CYPE 3D, we have a 3D view, and we can see that we are talking about the exactly same model. We are at the same project, okay? So we can open the 3D view here, and we can see the model and the architecture model here, the same architectural model, okay? You can see here the same information. That's very useful. Two different programs, two different purposes. One could be used, for example, by the architect, another one by the structural engineering, and we can connect the information from one software to another, okay? Here, during the calculation, during the design of this software, you can see that the analytical model was developed considering different type of conditions here with different sections. And we can, for example, see here the elements. The elements, they are in green state. It means that everything is checked according to a specific code that was selected. And here we can also see, for example, the forces. For example, here, I don't know, considering the envelope of forces, we can see the relationship between stress and resistance on these bars. So we can see that most of the elements, they are in a very good state. There are no problems here. So yeah, maybe these elements are even sections that are too big to this project, but for architectural purpose that could be necessary. So yeah, we are just checking the project, and it was analyzed, okay? It was analyzed, no incidents. So if it's analyzed, there is no incidences, we can share this information, again, sending the information because we are connected to the same project, in the same account, with the platform, with the server center. So I will share this information, share now this new IFC that I will call structure, for example. Here is the first thing that we must know when we are designing connections with CYPE Connect. We are not yet at CYPE Connect, but it's important to know that when we are using one of these CYPE software like CYPE or Strubing CYPE 3D, you can send the forces, the loads that were calculated here in the main model to CYPE Connect, okay? And to do that, you must check this box here, okay? So you must export the forces that were calculated here to BIMserver.center, and then when you open this model at CYPE Connect, you will download this information, and that's going to be more precise to design your connections, okay? Of course, if you don't export this information, you still have possibilities to calculate the connections at CYPE Connect, but you need to enter this information, enter the load cases, the combinations manually. So it's going to be more complicated. You have too much work to do. So you can use this option here. It's just a check, but it's a very important check. So let's accept. Let's export. It was very fast. As you can see, the export test was finished, and a file with IFC extension was generated. The structure.ifc file was generated, and in this route we have a local copy of this file. Okay. All right. So we are ready to jump to the third step, the most important step in this presentation. So we'll open CYPE Connect. So we are using the version 2022E, E of elephant. If you are watching this recording in another moment, please check the BIMserver.center platform to download the last version. Maybe this presentation have some days, some weeks. Okay. And here we'll just start a new project. So I'll create a new project that I will call Deck House, for example, and I will select the project that where those files are stored. So the Deck House project that was created some hours before. Okay, so I'll connect CYPE Connect with the project called Deck House. So I'll click here. Here inside of the project Deck House, now at this moment we have two IFCs. One IFC that is related to the architectural model, CYPE architecture, and another IFC that was generated with Strubing CYPE 3D that is called structure. Okay, we can import all the IFCs that we have in the project. Okay, we can import everything, but of course not all the information that is imported it's relevant to our to this phase of our project to develop the connections. For example, the architectural model in this situation could be useful to view the model and check if the information is in the right position. But we will not use the information from the trees, from the chairs, from the walls, from the ceiling to develop your connections. So if you want, you can deselect the CYPE architecture IFC file and use, for example, just the structural model. Okay, you can choose that depending on the size of your project, depending on the time that you have. Of course, more IFCs in this list, more size in your project, more time to load everything and then export and import everything. My recommendation: import just the structural model. You have a model that it's going to be cleaner and it's going to be easier to work. Okay, so I will import this one. And here there is another option that is very interesting. That is the option to generate the nodes automatically. Okay, so you can choose if you want to generate the nodes automatically or not, depending on the size of your project, depending on the details that you have. In some situations, the nodes, they can be very, how can I say, they can be very near between them, and then could be very complicated. You can have too many loads in the same place, too many nodes in the same place. So you can uncheck this option here and then generate the nodes automatically. I will show you how to do it in both situations, okay, with both options. To start, I will generate the nodes automatically. So now we are importing the BIM models. We have just one BIM model, the structural model. And when we start importing this model, the first thing that CYPE Connect asks to us is, if you want to import everything that we have in our structural model. At this moment, CYPE Connect found two different sections, in this case, two different rectangular sections in the structural model. So there are 35 bars with this section here, rectangular 16 per 16, with a material that is kind of wood with 30, resistance of 30, and then 63 other bars with another size, 10 per 18, okay? At these buttons here, CYPE Connect found in our library, in the library that we have by default at CYPE Connect, two sections that are with the same sizes here. Why? Because the sections that were used at CYPE 3D have this exactly the same name that the sections that we have in the library created at CYPE Connect. And by default, the sections that we have here at CYPE 3D, when we define a bar, when we describe a bar, for example, these sections here, okay, these names that are here by default, including those that you can download by the predefined series, they have the same names that the libraries that we have inside of CYPE Connect. So if you are using the libraries that we have at CypCAD or CYPE 3D here at CYPE Connect, you will always have this situation here. The sections from the BIM model, the structural model, they are correlated with another section is here. If here at CYPE 3D you created a new section with a new characteristic, with a new name, with a new disposition, then you have to create a new one here by creating steel or timber section, or defining a material, a service class. So you must create a new one to import this information to CYPE Connect, okay? So yeah, here it's perfect. So we import all the elements that we find. So let's import this information to CYPE Connect. All right, so here we have the model that was imported from StruBeam Site 3D. By default, we can see the screen divided in two parts. Here on the left side, we have a list of the nodes that were created. So we have a huge list here with all the nodes. If we click on a specific node here, we can see the 3D view of this node here, and also we can see that the node is highlighted with a different color in the 3D model. Okay, so we can navigate by clicking here, look in the details of the node here, and we can also click on the node on the 3D model, and it will be highlighted here on the list. Okay, the 3D view that we have here, we can personalize it. For example, we can activate here the option to represent it on the axis how can I say, visualization, or the 3D model visualization. So we can see the sections here. Okay, these are the sections that we imported from CYPE 3D. As you can see here, this bar is the same bar that we have at CYPE Architecture, StruBeam Site 3D, CypCAD, CYPE Plumbing, all the softwares that have a 3D model that CYPE develops have these options here. So for example, here you can create a specific projection view or a 3D view, and you can, of course, orbit, zoom, or pan your model using the tools that are common to every software that CYPE develops. Okay, as you can see here, all the nodes that were imported from CYPE 3D, they are with this warning symbol, because these connections were not defined yet. Okay, so we must design and then analyze and check these connections to every node of this structure, and we are just starting. Okay, so during this presentation we'll create one of them, then after we finish that, we'll jump to another example with different nodes that were calculated before, just to show you the different possibilities that we have here with the application. Okay, so I selected, for example, let's select maybe this one here that it's very interesting, or maybe this one. So for example, I think this one is going to be a good example. But before we start, let me show you one detail. Okay, here we have three groups of tools. Okay, the first one, the project, the general setup that we can do here in the software. The first one, defining the codes that we are using. So here we can select the codes to steel elements or to steel sections. So we have different codes here, the Euro code, the Spanish code, the British standard, the Brazilian standard, the American standard. So here we have different codes. And to timber, at this moment, after the launch of the version 2022E, we have the Euro codes. In the future, we will be implementing more codes also to timber elements. Okay, so here you can select the codes that will be used to check the connections that we will design. The second point that we have here is that there are the libraries. So here we can create the types of steel, for example, that will be used in our elements to develop the plates, to develop, I don't know, one profile that we must add to our connection. Here you define the mechanical properties of each steel. By default, we have this list of the steel here, but you can create your own list. Okay. The same thing to the screws, for example, or bolts in this case, with the reference, description, the mechanical properties. The same thing to anchors, or here to wooden sections. So you have here different type, solid and also glued, laminate, homogeneous and combined sections or materials. The same thing to dowels, for example, you can add here. You can create your series of bolts, screws here. You can also create specific elements for concrete to connection with concrete. Once you define the materials, you must define the series of elements. For example, here we have rolled, simple and angle elements in the rolled elements, and also tubular series, different series. For example, here this series, you can create your own series and edit one of these, adding the different profiles, the different sections of one specific series. It's interesting that we have these buttons here. With these buttons, you can export the series that are here that you've created before to your computer, share this information with a colleague, for example, or import this information again in your next project. And here you can also download predefined sections from different manufacturers that are present in the CYPE software at CYPE, at CYPE, and now here at CYPE Connect. So you can import this information too. Okay, the same thing to the wooden library. Okay, and for example, to define the welds, everything can be defined here. Everything that was defined once here, you can also export as a global setup or your global library, let's say that, using these buttons here. Okay, so it's very useful. Set up this information once and then export, and in the next projects you don't have to think about that. Okay. Here the next group of tools is the node group. Here we have some situations. Let's imagine that one of these nodes wasn't generated correctly because the element it was too small, or maybe because we had a problem during the development of the main model. Okay, so we can delete this model by clicking, using this button here and clicking on the node. Okay, so now we don't have this pyramid that is the symbol of a node. So here we don't have a node. We cannot generate a connection, design a connection, because we don't have this node here. And you can create your new node by clicking here on the new button, select the bars that are related to this node with your left mouse button, the button left of your mouse, and with the right button of your mouse, you can confirm that operation. And here you can see that there are three elements, three sections, V1, V2, P1. Here you can define the sections, you can change the information if you want. You can adjust this information if you think it's wrong. And once you define this information, you can accept, and the node will be generated. Okay, so this is the way, the more manual way to generate a node here at CYPE Architecture. In most of cases, you just have to import the nodes as we made before, and everything is going to be okay. Okay. Once we create a node, we include the nodes. In this case, we have all of them from side 3D. We will design the connection. Okay. So, for example, let's use this button here to edit one of these nodes. For example, this one, and start designing our connection. All right, so here we have the node, and now we must use the operations that we have here in this part of the window to these different operations to design the connection. Okay, once we designed the connection, we'll jump from the model tab to the analysis tab, and then calculate and check if this connection is okay or not. Okay, so in this case, we have here, first we have one continuous element that is a continuous section that is the V3 beam, okay, the V3 bar, this one here. And then we have two single elements, V1 and V2. They are not the same element. Here we have one single element, but here we have two separated elements, okay? They are not the same. So we have different situations here. And then we have another one, a vertical bar or a column that is called P1 here, okay? We must connect everything here and analyze it. So let's start. The first thing I want to do here is adjust the P1, okay? I would like to adjust the section because in this position it's impossible to add plates or bolts or any other element. So the first thing I'll do here, it's an operation of adjust a section. So in this case, I click it here, and one operation was added to my list of operations here. Okay, so the first operation, it's adjustment. So I will adjust the section P1, okay, according to the top face of the V3 element or the V2 element. They have the same size. So for example, adjust to the section V3, for example, to the nearest face of the V3 element, okay, the V3 section. Could be to the furthest face, to the top face, to the bottom face, to left face, in this case, to the nearest face. And as you can see, the V3 that was here in the middle of the V3 section, now it's here. It was trimmed here on the top of the V3 section. I can also add a displacement. For example, let's suppose between the P1 section and the top of the bars, we'll add a plate with, I don't know, 8 millimeters. We can also add a little displacement here of 8 millimeters. If we change it for 2 millimeters, look, now 2 millimeters. Here, 8 millimeters. We have this possibility. It's perfect to add a plate in this space in a next operation, okay? The same thing I'll do here with the elements V1 and V2. These elements, they will be connected to the V3, that is the main bar at in this situation, but we must adjust these elements and add a little space between them. So I will duplicate here the operation and just change the parameter P1 per V1, okay? And it's gonna be the same situation. It's going to be adjusted to a section. The section is V3, and again, the nearest face of V3 of V1. So now we have that situation. Okay, we have this little space here, and the V1 it's adjusted. Okay, the V2, let's do the same. Let's duplicate and select the V2 again to V3, the nearest face, and also with 8 millimeters of space. So now we have all the elements. They have the best size to now we can start adding the metallic elements that will connect the elements that we have here. Okay. I'll create three connections. One connection it will be between the V3 and P1. It's going to be a kind of T format connection, metallic T. It's going to be inside of the sections. They will not be visible, okay? And then we'll create also the T elements to connect the V1 to V3 and then V3 to V2, okay? The first one, for example, the V3 to P1. To do that, I'll add some plates. I'll need two plates to create this T element. Okay, so I'll add a new plate here. A new plate. This plate, I can choose the material of this plate. So those materials that are in my library that were included before, I can select it here. So let's suppose it's this still here. Then we can define the geometry of this plate. For example, 8 millimeters, 8 millimeters plate. Could be a rectangular plate or a polygonal plate. If it's a rectangular plate, we just define both dimensions to this rectangular plate. If it's a polygon, here we have a table where we can add a different lines, and each line is one of the vertices of this polygon. We can create here, defining the coordinates, the type of section, and then we can create a polygonal plate. We can add all the elements that we want, and this table, with the right button of your mouse, you can copy the cell, copy the column, copy the table. For example, to copy the information from here, send to Excel, manipulate it on Excel, then paste here. So this table, you are able to copy and paste information from this table. Okay. In this case, we will work with a rectangular plate. Okay, very simple rectangular plate. At this moment, I will leave these dimensions. Then we can change it if it's necessary. Okay. Where is the position of this plate? The position could be a plate to connect something, could be attached to something, or perpendicular to something. For example, attached, we can create a plate, the plate 1, okay? That would be attached to the section. That could be a plate, a section, or a reference plane. For example, attached to a section, that is the section V3, okay? And to the top face, the bottom face, the left face, the right face, the top face of the V3, okay? We cannot see yet. Actually, we can see it's there. This is the plate 1 that was included in our model at this moment, okay? This is the plate 1. It's too difficult to see it. It's almost inside of our connection, almost in the center of our node. So here we have the view options. We can change the visibility or the style of some elements to be easier to see what is happening inside of our model. For example, the sections, I will change the drawing to the transparent view, okay? And I'll maintain the plates, the bolts, the anchors, the welds, and the fixing elements for timber in the solid style, okay? Let's accept it. And now we can see that the plate 1 was introduced inside of our model, okay? That was the operation to add one plate. It's one plate. I need two plates to create a kind of T format element that will be inside of P1. So I will duplicate the plate 1, okay? I'll maintain the same material, the same thickness. At this moment, it's going to be the same size, okay? But now it's going to be another type of plate. For example, a connection plate. A connection plate that at this moment, it's in the coordinates 0, 0, 0. So exactly in the center, in the node of our connection, okay? Now I can apply some displacements or change the angle to move this plate to another position. For example, let's try changing one of the angles. This one, for example. Here we have one situation. It's not the best situation for us. So I'll come back here. Or the second one. Here, yeah, this is a good situation. I have the angle that I need, okay? But it's not in the position that I need. I must add some displacements in one of the directions. For example, let's try 100 millimeters in the I direction. No, that's not good too. Let's come back. In this direction, yeah, maybe this one is good, but 100 it's not enough. 120. Let's try. Almost. Okay. Let's use one of these views here. 120, 140. 140, it's good. We are creating the T form or the T format element that will connect the P1 with the V3. Okay, we are starting creating this element. This element was included here, but now just defining this distance, the plate 2 could be we could have not too much precision when defining this element. So it's more secure if we trim this plate, for example, the plate 2, okay, using the plate 1 that was generated before as reference. For example, using this operation here, the trim plate, we can trim the plate 2, creating a slice using the plate 1, or maybe it's better, on the front face of the plate 1 as a reference. So now we are secure that the plate 2 is connected to the plate 1, or have a size that is it's compatible with the plate 1. Okay. We can also add a sub operation of welds, adding welds to connect the plate 1 to the plate 2. So by using this button here, we add the welds, okay, in both sizes, in this case, connecting plate 1 to plate 2. There are different configurations here to define the welds. For example, if you want to the weld just in one of the sides, in both sides, okay, we can change the way that we will define the size of the weld. We can change the format of the weld. We can select electrodes. In this case, we don't have one, so let's create one with a specific characters here. We can add displacements in the initial and final parts of the weld. For example, here, adding 1 centimeter, 10 millimeters of displacement. In this case, I will use the full size here. Let's add 0 here and 0 here. So you can change the information that is related to the welds. Let's save it. So the first thing that we made, that is, I think it's one of the most important parts of the connection, is to create this element, this structural element that will be inside of our model, but that was created using 2 plates and one adjustment to adjust and connect the plate 1 to plate 2. Okay, let's do the same thing to connect the V1 and V2 to V3. Okay, so let's start, for example, with V1 to V3. Okay, to do that, I'll duplicate the plate 1, and the plate 1, it will be the same plate that we've created before to P1, but it's gonna be not on the top face of V3. It's gonna be on the left face. No, left face, it's the other side. In the right face of V3. So we have this situation, okay? And let's duplicate the plate 2 to create the plate 4. And in this case, it's gonna be also a connection, but the local axis, it's gonna be another angle. So for example, in this angle, and the displacement, it's gonna be another. So for example, 0 in Z, and in Y, let's try 140. No, it's not okay. So in X, 140. No, it's to the other side. So minus 140. 140 is too much because here the section is a little bit smaller, 100, for example. So now we have the T in this position here, created with the plate 3 and the plate 4. Now we must create a similar operation to adjust and weld plate 3 to plate 4. So let's duplicate the plate operation. And in this case, the plate 4 will be cutted according to the position of the plate 3, and we'll use the same welds. And now we have another element. As you can see, once you create the first elements, you just have to duplicate the operations, and it's going to be much easier and more precise because the parameters You not change the parameters like the size of the welds, the size of the bolts, the size of the screws, the size of the plates. Just by duplicating the operations, you can save a lot of time. Okay, let's do it again to connect the V2 to V3. Okay, so I'll do the same. The plate 3 will generate the plate 5. In this case, it is still the V3 beam, but on the left face. Okay, so now we have here the plate 5. And let's do the same. Oh, sorry, not with this one. Let's use the plate 4 to create the plate 6. Okay, and here we just have to change the position. If it was minus 100 millimeters, now it's positive. So we have the element here. Okay, and this the operation to adjust and add the welds is the same. We just have to change the plates. Now we are welding the plate 6 to the plate 5, and now we have the elements here. Okay, so let's save it. We have the main elements to connect the bars here, but now we must start connecting these elements to the bars. Okay, so to start that, I will start connecting these elements that we've created to the V3. That is the main bar that we have here. Okay, so I will connect everything to V3, and then I will connect the elements to each bar. Okay, to do that, I'll start with the P1. Okay, the element that's here inside of P1. So in this case, I will connect the bottom, this bar that is here on the bottom of the element, the horizontal plate, the P1, with the V3, with the top of the V3 bar. Okay. To do that, let's use here the timber elements. We are working with sections made by timber, so we must use these elements here. Okay. This is one of the new features that were just released some weeks ago with this version. Okay, now you have this new button here, and you can add dowels, bolts, and screws. Okay, in this case, for example, I will add some bolts. Okay, I'll add some bolts, and I use these bolts. What is the situation that we have here? We have a steel element, okay, that is the plate, and a timber element that is the V3 section. Okay, so we have here the V3, and we are connecting these elements here. These elements we are connecting the steel and the timber element. The steel, it's a plate, so it's the plate 1 in this case, and the timber element, it's the V3 bar. Okay, so we are connecting these elements. And now let's add some bolts. Let's add the first one. The first one in this position, 0 and 0, it's right in the center of the plate. Okay, let's add some displacements here. For example, 30 millimeters on the X, or maybe better. Let's start with 30 millimeters on the I. Okay, we have this bolt here. And let's duplicate this bolt and change to minus 30 to generate a second bolt. Okay, this bolt was included here. That is connecting the top of the V3 to the bottom of the V3 to connect the element to the V3 bar. Okay. Once we define the position of the elements, we must define the type of bolts. Here we have the bolts related to this code with different nominal diameters, but you can create your own library of bolts. Okay. So for example, I use this one, 8 millimeters. Okay. And then the material of the bolts. I can select the material of the bolts, and I can add some spaces here, space to steel, space to timber. We can reverse the direction of the bolts if it's better to during the construction phase. So we can change that. Yeah, but here we have 2 elements. Maybe in the future we'll add more elements here, more bolts. But to start, I think it's interesting work with these 2 elements, and then we can come back to the bolts 1 operation and add more bolts if it's necessary. Okay, all right, let's save it, and let's duplicate the bolts operation to add more bolts to connect this plate, the plate 5, to the V3, okay? Here we have a different situation because actually here we have two plates. It's one plate, one section, one timber section, and another plate. So we can use one unique bolt crossing the three elements, this plate, section, plate, with a single bolt. Okay, so let's do that. I'll duplicate the bolts one operation. We'll generate the bolts two operation. And the situation here, it's not that one, the first one. It's something similar to this one here. One plate, one timber element, another plate. Okay, this is the situation that we have now. So the first steel element is the plate 5 element. If we don't remember the name or which is the plate, we use the mouse to check. This is the plate 3, this is the plate 5. So we are connecting the plate 3 to the plate 5, okay? And between them, we have a timber element that is the V3, okay? So yeah, let me see. So we are connecting the plate 3 to the plate 5. Sorry, here there's a mistake. Plate 5 to plate 5, it's impossible. So yeah, here we have a problem with the bolts to operation because the select elements are not compatible. Why? Because it's plate 5 to plate 3. And now it's okay. Okay. So now we have this situation, and as you can see, as we duplicated the bolts 1 operation to create the bolts 2 operation, the bolts were added in the same position, and now they are crossing. We have a clash between the bolts from the first operation to the second operation. That is impossible. So let's change the position of the bolts, adding here, for example, some displacements on the x axis. For example, here 20, and for example here 20. And I'll duplicate this guy here, adding in another one, for example, to minus 20, and duplicating this guy here, also to minus 20. And we have 4 bolts that are not colliding with the first bolts that we introduced in the first operation. We have some space between them, okay? And as you can see, if we deactivate the sections, let's deactivate the sections. I think it's not possible to deactivate, just to put it on transparent. But using here, for example, this option here, the clip volume. Okay, let's add a section, a temporary section here. Just doing like this, somewhere here. I think here it's gonna be possible. As you can see here, the bolts, they are connecting this plate to this plate, crossing the V1 element, okay? That's very important. All right, so just coming back here. Okay, so now we have the elements they were developed, the 3 elements that we will use. They were connected to the elements, but I think here on the first element, just 2 bolts, it's not too much, so maybe we must add more bolts here. The problem is that we don't have too much space, so I will change the size of the plate that we introduced, the first plate, this one here, the plate 1, to have more space to add more bolts here, okay? So it was the plate 1, okay? So I'll change here, it was 100 per 100 millimeters. Let's change the dimension here. When I change it, as you can see here, I have this situation. This is not good. Let's come back to the other one here. Now we have the plate 1 a little bit bigger. Maybe it's too big. Let's try with 160, for example. Yeah. Now we have this element that is a little bit bigger. Although the plate 2 here is not that big, but the plate 1 that is under the plate 2, it's a little bit bigger, and then we can add more bolts easily. Okay. So to add that bolts, I use this view, for example, because here I have 2 bolts, then I have these bolts crossing, and I have to add another line of bolts here and here. Okay. So in the bolts 1 operation, I'll duplicate the first bolt, adding, for example, 40 millimeters. Let's try 40 millimeters. I think it's okay, or maybe 50. Let's try 50. It's better. Okay, and then I'll duplicate the 50 and add more bolts, just changing here the coordinates. Okay, so 50 and minus 30, minus 50 and minus 30, and minus 50 and 30. And we have 6 bolts, and now they are not colliding, as you can see here, because we changed the position. But the bolts, we have space to create these bolts. We don't know if it will be enough, if we will have resistance, if the stresses are too concentrated in a specific point. We don't know that. When we calculate that, when we analyze that, we will know. But at this moment, we are just trying to introduce the elements. Okay, then we will check and define if it's a correct position, if the size of the elements is good or not. Okay, we are doing the first intent. Okay, all right. So everything is connected to the V3 element, but now we must connect V1 to the metallic elements, V1 to the metallic elements, and V2 to the metallic elements. So let's do that. To do that, I will add some dowels. Okay, just to use another element. For example, I will add a dowel. Our situation now it's this one. We have one timber element with a specific plate with a specific steel element inside of the timber element. So the timber element could be, for example, the P1. Okay, the P1, and inside we have a plate that is the plate 2. Okay, let me check. Yes, P1 and plate 2. Let's add the first dowel. The dowel is there in the middle because there is a displacement here. So let's try adding a displacement here. 200. 200 is too much. Let's try 140, for example. Almost 110. Let's try. 120. Yeah, 120 it's a good position. The door is here. Okay, let's duplicate the door. Let's add, for example, 160. No, 150. It's gonna be better. And then let's add 180. Sorry, that was not a number. Now a number. Yeah, maybe we must reduce a little bit. 5 millimeters in each case. 145, 175 here. Okay, and now we have these elements there, and it's connected. The doors are connected. The element is connected. We must define the type. So here we have the list of doors with different nominal diameters. I use just 8 millimeters, and the material is gonna be one of the materials that I have. We can add some spaces again, okay? And these doors were added in our model. Let's duplicate the doors and do the same thing to connect V1 to V3. So this plate here. So it's gonna be the timber element is gonna be the V1, and the plate is gonna be the plate 4. Plate 4. And we have this situation. As the section is with a different size, the displacements are different. So let's try with, for example, 85. 85, almost there. 75 maybe. 75, it's a good number. 75. So here 105, for example, and here 145, if I'm not wrong. No, 135, sorry. 135. Yeah, and we have the dollars here. Okay. We can save it and duplicate the dollars 2 to create the dollars 3 operation. And then we have the V2 to the plate 6. Plate 6. Okay. And yeah, it's done. Here we have the dollars in their position. With those operations, so we created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 operations to connect this this node. It's not a simple node because we have hidden connections. We have 4 bars, could be 5, could be 6, depending on the configuration. And one of the bars it's continuous, and another one it's separated. So it's not a simple node, and it was necessary 17 operations. Okay. Before we calculate it, let me show you just some other tools that are important, interesting. Here we have an option to measure something. So you can select something and then, I don't know, to calculate the distance of, I don't know, a screw or a bolt. You can use the measure tool that is here. You can change the view options that we have been looking before, and you can also change the size of these sections, because now we are representing just a part of the structure here, just some distances. Actually here we are seeing just 400 millimeters of V1, V2, P1, and V3 we are looking 800. Okay, so you can change this information, and the size of these elements can be increased. Okay. And one thing that is very, very interesting is the library. So you can export all the job that was made here, all the operations that you created here, to use this connection and other nodes that are similar. So just exporting here, you can add a name, for a code, a name, I don't know, just using here my particular codes. So yeah, a reference, I export it, and then I can import it again in the future. All right, so here inside of the analysis tab, we have the options to analyze the model and then to read the results, okay? The first thing is to generate information, or to define how the information that was generated in our structural model will be imported here to this analysis. So here we can change the maximum and minimum absolute values for the forces that were introduced using CYPE 3D. In this case, it's proving CYPE 3D. You can add some filters here, depending on the complexity of your model. That could be useful. Okay. In this case, I'll maintain these parameters. Here you can see the load cases. These load cases were created automatically. These load cases are here because when we decided to share this information, we checked this button here, export forces to design connection. It's why this table now have these combinations with different parameters. We can also add new load cases here to simulate something that was not included on the main model, or even delete something if we want. Okay, but in this case you don't have to add it because it was imported from the structural model. If you are using CYPE Connect with other softwares, we analyzing structures that were calculated with other software that are not made by CYPE, you can still add your load cases here by manually. Okay, so you can use CYPE Connect with other CYPE softwares or not, depending with the software that you use. You will import this information automatically or not. Okay, the same thing here to the loads. Here, for example, in the V2, we have the 2 load cases that were in the table that we saw before. And here, the different loads that are applied to this element in this node that we are analyzing, to the P1, to the V3, okay? You can also change this information. You can delete, you can add, you can change these parameters. They are editable, but this information was imported from the BIM model, so it's the most precise information that we have at this moment, okay? And here we have some settings to the design options. For example, you can change the size of the element, the length of the average stresses. So here we have some parameters that you can change. Then it's just click on analyze and wait the design process that we analyze using the Opensys engine. That is a very powerful and famous engine, or that is developed by the University of Berkeley in California. Depending on the size of the connection and the numbers that the type of elements and number of elements, you need more or less time. Okay, in this case, just 30 seconds or less, we have the results of this element. Okay. After calculated, the first thing that we can see here is that the color of our elements are different. Okay. We can see that some of them are in red color, some of them are in green color, in yellow color, and those colors, they are related to this bar that we have here. Okay. These colors, they represent the maximum demand capacity ratio. It's the ratio between the forces and the resistance of each element. For example, the elements that are in green color, they are it's very safe to maintain these elements because the ratio between stress and resistance is very low. It's under 20%. But for example, these doors or these bolts, they have more than 100%. It means they are not okay. We have a problem here. We must change the size of the bolts or the number of bolts because there is a problem here. In the yellow cases, we have a situation that is between the first and the second. Okay, so it's a 3D way to verify how the elements, how the results are, what are the results of these elements that we have in our structure. Okay, if we click on this one of these elements here on the right side, we can see the checks that were made with these elements. Okay, for example, if we click here, only show the failed checks, we can see that the doors have a lot of problems here because they are not according to some points that are included on the code that was selected that we want to check. So yeah, here we have problems. We must change these doors. Okay, if we click here on the bolts, for example, these bolts here, let's try to click on them. Yep, and here we can see, or for example, this one here, or on these plates here, everything is going to be okay. So it's going to be in green. Yeah, here the plate is perfect, no problems, everything is on green. The problems are on those that are on red color. Okay, by clicking here on the summary, we can see the results. For example, the components that we have, the loads, the checks, the nodes, they will have different reports. For example, this one is very interesting, the checks. We can see a list of the checks to each element, the plate 1, plate 3, plate 4, plate 5, plate 6, the weld that was added, all the parameters according to specific load cases and specific points of the codes that were selected. So as you can see here, this list is huge, and we are looking the checks just for this node, this connection. We have dozens of them in our project. So here you can see that it's impossible to check, to analyze this kind of elements manually. You must use one software like CYPE Connect. Okay. After that, we have another option that is very interesting, that is the von Mises stress. So we can change the von Mises stress, and then you can see how the stresses are applied in the plates that we have. In this case, we have different situations according to the load cases that we have. We have 2 load cases. So if we click to another one, we have, it's pretty similar, but it's not the same. Okay. So this is, again, it's very useful to know what is happening with your plates. Okay. Here we can see that near the bolts we have too much more stress. Okay, it's a normal situation. Okay, here you can change some parameters to see this information, applying some filters. Could be a discrete representation or a continuous one. If we change, we see that is a little bit more soft or smooth. Okay, it's a continuous representation, and we can add minimum and maximum values. Here we can see that in the blue color, the stress is 0.35 and the maximum is 213. if we limit here, for example, everything that is more than 150, okay, that's going to be somewhere here. Everything more than this, it's going to be on red color, okay, because the maximum is going to be 150. If we change the minimum, more than 40, okay. So here 40 is the minimum, and then we can see the colors more accentuated, okay. It's very useful in some situations when we have too many difference in the same element. The same thing we can do with the equivalent von Mises deformation. So here also by load case, so we can see the deformation, the von Mises deformation here. Okay, it's very interesting too. And we can see the displacements. Okay, the displacements here. We can add a scale to these displacements. I don't know if we add, in this case, a scale of 100, we can see what is happening according to the load case here, okay? So yeah, that would be very, very useful to define the best elements to your connection, okay? In this case, our connection, it's not okay. We have a lot of problems in the boats and in the doors of our project. We must change it. I don't know the best way, maybe changing the dollar, the size, the number. I don't know. We must change in the model and then come back and analyze again until we have everything on the green state. Okay. I will not do that because I think just showing this this connection in this state, it's a good example. To change it, just come back to the model and personalize the operations. Okay. But I would like to show you two things before we finish the presentation, okay? The first one is to come back here to our model, okay? You can see that the connection was included here. Let's change the view to the axis. It's gonna be better to see. So yeah, here we have the beam model of our connection. It was not just calculated and checked, it was modeled. So now we can export this information to BIMserver.center again, and then we can view this information in other softwares. Okay, so we can integrate the connections in the project. This is one thing that I think it's very nice. And if we come back here to BIMserver just to a very fast test, let's add more loads to this project. Here in this project, I was working with panels. So I will edit the panels, the loads on panels that we have here. So in this case here, I will add more loads here. Let's add another load case here. Just let's duplicate the loads here, just to have an idea. We have much more loads now, and let's analyze it again very, very fast. Okay. And let's export this information to BIMserver.center again. Okay, so BIMserver.center, share, export the forces. It was exported. Let's save it. Let's come back to CYPE Connect and let's update. Let's update. We'll maintain the BIMServer 3D model that now have changes selected. So let's accept. We have the same elements. Let's accept. And now we have this element. The geometry didn't change it. So now we have the same node. We can just enter and analyze this node again, but with another load. Jumping to the analysis tab. Here on the load cases, we have the same load cases, but I'm sure that the numbers here related to loads are different. If we analyze it again, let's analyze it again. I think it's going to be no more or less 30 seconds. Let's see. We'll see the difference. Now, as you can see here, we have more problems because the loads are higher. So now we have also problems in the plates, not just on the bolts and doors. And those plates that were yellow, the past situation now are in red color, in pink color, almost 100%. These plates here, it's more than 100%. What I mean is, by changing these elements, the information that is here, everything is connected. You can send and receive information at any moment from one software to another, and then you just have to update and analyze again, of course, but you don't have to add more information. It's live. You just can add and these changes and update the information. And the best part is that you can choose when you update. If you don't press this button of update, this information will not be updated. Okay. So that was the presentation of today. This was my part. I hope you have enjoyed it. You have learned a little bit. I know Marta have been typing some answers that we received through the chat. And I don't know, Marta, if you have any other comments to conclude this presentation. I think this was the part that was planned to this presentation today.
Hi again. Thank you very much, Afonso. It was a really nice presentation. I really enjoyed it. And I just wanted to add, as I said at the beginning, that that I wanted to share again my email address, which I already put it in the chat. And I also wanted to show again where to download the application, which I'm going to show. Can I have the control back? Can I show my screen?
Yes.
Sorry.
Sure.
Oh, you can show it. Oh, that's okay. You can show it. Just
so
if you want.
Yeah, just searching for connect two ends.
Yeah.
So side connect is here.
Yeah. So you go to this platform, to our BIMserver.center platform, and then just download it from there. You will have to create an account, but that's easy. It's very easy, and it's free of charge. So you can download it for a month and try it for a month for free. Okay, so that's all I wanted to add, just to remind them about this, my email address and the website where they can download it. And I just wanted to say thank you to everyone for their attention, and I hope they enjoyed it.
Thank you. See you in the next opportunity. It was a pleasure.
Yeah. Okay.
Bye.
Goodbye.